Welcome to Unit 8 of Algebra 2. This is on sequences and series. Today's focus is going to be on arithmetic sequences. So day 1 in our notes. Okay, so first of all, what is a sequence? A sequence is formally defined as a function that has its domain as the set of positive integers. So for instance, 1, 2, 3, 4, 5, 6, and so on. And a sequence is a set of terms written in a given pattern. So a lot of you guys probably learned the chant when you were little, 2, 4, 6, 8, who do we appreciate at the end of a game? I know I did. 2, 4, 6, 8, that's an example of an arithmetic sequence. So this is a set of terms in a specific order, each having what we call a common difference. So when I said 2, 4, 6, 8, my common difference was 2. Now, I have a picture of a sequence on the right here, where on the bottom, these are like your term numbers. So first term, second term, third term, and so on. And then these are the actual terms themselves. So the first term is 10, the second term is 15, the third term is 20, and so on and so forth. So I'm going up 5 for every one increase in term number. Up 5 over 1, up 5 over 1. Now, this idea of doing up and then over, or rise over run, should give you an idea of something we've talked about before, and that is the slope. So in this linear pattern that you guys are seeing, but it's not actually a line because you're not connecting it, you're seeing the common difference is 5, which is equal to the slope of those points. Now, if I give you an example like 25, 22, 19, you can see that we're going down by 3 each time, which means our common difference is negative 3. So your common difference can be positive or negative, depends on what's happening. An arithmetic sequence represents a linear function. Now, like I said, it's really just the pattern. You're not connecting these because it's not like there's a term 1.5. Okay, and by connecting, that would imply that there would be. Whenever you guys hear the term arithmetic sequence, I want you to think adding. And I remember that because arithmetic is adding. The A is associated. All right, so for the sequences below, identify if each sequence is arithmetic. If it is, determine the common difference, and if it's not, then just say it's not. So here's a moment where I'm just going to give you a little bit of time to think about it, and then we'll go over the answers. All right, so hopefully that was enough time where you paused the video to give yourself enough time. So the first one was arithmetic, common difference of 3. Second one is no, though. Although there is a pattern, if you notice, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8. There actually is a pattern, it's just not an arithmetic pattern. This is something called the Fibonacci sequence, named after Fibonacci, who discovered it. And we actually usually start with 1, because 1 plus 1, or sorry, I should say we start with another 1. 1 plus 1 is 2, 1 plus 2 is 3, and so on and so forth. So it's not like there aren't sequences out there that exist, like patterns that exist, it's just they're not all arithmetic. So then the third one, which I know my lettering is a little bit weird here, here's B. This, be careful, you're multiplying by 2, so that's not arithmetic. That's actually geometric. We'll talk about that tomorrow. And the fourth one, you're going down by 4 consistently, so that is arithmetic, and the common difference is negative 4. All right, so how do we express our sequences? First is an explicit notation. This is where we have something called A sub n. So I'm going to write that down. A sub n. That's how you say that. That's a formula for the nth term of a sequence. So like if I wanted the 99th term of a sequence, I would do A sub 99. So for example, A sub 1 is the first term, so that means A sub 3 would be the third term. Now, it works a lot like a function that you guys are familiar with from Algebra 1. If I say f of x is 4x plus 2, and I want to know what f of 5 is, I would do 4 times 5 plus 2 by evaluating x at 5. That's 20 plus 2, which is 22. Same idea over here at sequences. A sub n is 4n plus 2. If I want a sub 5, or the 5th term, I would substitute 5 in for n. 20 plus 2 is 22. So explicit formulas are great because once you know the formula, you can find any term you want by just substituting in the value for n. Now, a recursive formula is one that is computed solely on the previous term. So I want you guys to underline this right here. A sub n minus 1 is the previous term. So usually we give it like this. There's always 2 parts. A sub 1 is the first term, so we always tell you where to start. And then it's a sub n equals a sub n minus 1, and then something happens. So I always read this as, if you want the next term in the sequence, you're going to have to take the previous term, and then the plus 4 means add 4. Okay, so for instance, if you know the first term is 5, this says take the previous term to get to the next term, which would be 5, add 4, and that gives you 9. Okay, you want this term, take the previous term, add 4, get 13. And then you can keep going. Okay, so that's your recursive formula. So on the next page, I have these summarized for you. Okay, so first being your explicit formula. This allows you to find any term of a sequence, and it's given by this formula right here. Please note that this formula is given on your Regents reference sheet, so it does not have to be memorized. Although I would recommend you memorize it because then you're just faster that way. Now, in order to use this, you have to be given the first term and the common difference, or be able to find it. Now, the next, which is your recursive formula, is not given on your reference sheet. Notice how I don't have the little stars in this box. So this you'll just have to memorize. So I'm just going to put a little star here. You got to memorize this. It's always given in 2 parts. I'm going to underline that right here. Where I always give you the first term, or you have to provide the first term, and D is your common difference. So again, it's always pretty much the same setup here. You have your a sub 1, and then a sub n equals a sub n minus 1. So if you want the next term, take the previous term, and then something happens. So are you going up by D? Are you going down by D? And so on and so forth. All right, so we're going to practice both, just because I know that that can look intimidating with the formulas. Write both a recursive and explicit definition for the following sequence. So first thing I'm noticing is my first term is 8. And it looks like we're going up by 4 each time, which would be my common difference. So for a recursive formula, there's always 2 parts. So I'm just going to do my little setup here. So a sub 1 equals something, and a sub n equals a sub n minus 1. Then something happens, right? So I'm just going to fill in, well, I know my first term is 8. And then didn't we say we were going up by 4 each time to get to the next term? So I'm just going to put a plus 4. So again, just to highlight where that's coming from, this plus 4 correlates to that, and the 8 correlates to that. So if you want the next term, take the previous term, add 4. Explicit formula, I'm going to write down my general formula. Okay, now let's substitute in what we know. I know the first term is 8. And I know the common difference is 4. Notice how I'm using parentheses because that's implying multiplication. And that's going to be really important when D is negative. All right, so you can either leave it here, which is 98% of the time how I leave it. In fact, I encourage you not to simplify it unless you have to because I hate for you to make a mistake. But let's say this is a multiple choice and that's not one of your options. You may have to clean that up and do some distribution. So in that case, I would have 8 plus 4n minus 4, which would then clean up to 4n plus 4. Okay, so either one of these is fine. The second one I just came up with is my simplest form. So let's say the problem asks for it in simplest form, then that's what it would want. Now something else you can do is double check in your calculator that you did come up with the right explicit form. So if I pull up my calculator, Let's type in this first guy. So actually, let's do the simplest form one. 4x plus 4. Now, if I did my work right, my table of values should show 8, 12, 16, 20, 24. Let's go back to term 1. And there you go. For term 1, it goes 8, 12, 16, 20, 24, and so on. So that just confirms for me that I did come up with the correct function or correct sequence equation to model that. All right, let's go on to the next guy. All right, back to recursive. A sub 1 equals a sub n equals a sub n minus 1, and then something happens. All right, my first term is 5. And to get to the next term, it looks like they're subtracting 3. So I'm going to put minus 3. So again, the minus 3, that's the correlation from the common difference. And the 5 is because that's my first term. Okay, let's go to my explicit model. Okay, a sub n equals a sub 1 plus n minus 1 times d. Now, some of you guys will leave it like that, and I will take off for you. Because what does that look like? That looks like subtraction, right? And didn't we say it's multiplication? So let's just make sure we include parentheses. Otherwise, you'll likely get the problem wrong. Even if, like, you're like, oh, Mrs. Pollard, I know it's multiplication. I'm just writing it like that. Doesn't matter. Notationally, that's subtraction. And secondly, you're probably going to forget that when I ask you to do stuff with that formula. Happens all the time. So just include your parentheses so that there's no mistakes. Now, I'm not going to simplify that one for this guy. You can if you want. I'm just going to leave that as my final answer. All right, let's move on to our third guy. Oops, I meant to write a sub 1. A sub 1 equals a sub n equals a sub n minus 1. All right, looks like my first term is 15. And it looks like we're going up by 5, so that means I'm going to put a plus 5 here. Okay, there's my formula. Do a little color coordination just like the last two. Want to be consistent there. All right, let's come up with the explicit model. A sub n equals a sub 1 plus n minus 1 times d. And honestly, the more often you write these formulas out, the more likely you are to remember it. I know my first term is 15. And my common difference is 5. Done. There's your formula. All right, so now let's put the explicit formula into action. Referring to sequence number 3, which is this guy right here, I want to find the 65th term. Now, anytime I'm asking for a term, I'm giving you a term number. So basically, I'm telling you n is 65 in this formula. So if I want to find a of 65, or a sub 65, I'm simply replacing n with 65. And now I can go to my calculator. 15 plus 65, I'm just going to make that a 64 because I know that's 64 right there, times 5, and I get 335. And that would be the 65th term in the sequence. All right, let's move on to the next page. All right, so let's do some context with these problems. All right, Jane works at a video game development company that pays her starting salary of $100 a day, and each day she works, she earns $25 more than the day before. How much does she earn on day 5? Pretty good job, huh? So, you can always just map it out. 1, 2, 3, 4, 5. There's her 5 days. Remember, she's earning $100 on that first day. And I'm going to add 25 per day. So this would be 125, 150, 175, 200. All right, so she's earning $200 on her 5th day. Now, since she's increasing by equal amounts over those equal intervals, so equal days, this would represent a linear graph. And if you're ever unsure, Here, down in the space below, we'll come up with it. There's 1, 2, 3, 4, 5. This could be 100, 125, 150, 175, 200 right there. Okay, so she's doing 100 the first day, then 125, then 150, then 175, and then 200. So take a look at those dots. Don't they look pretty linear? All right, what kind of sequence? Well, this is arithmetic. Oh, and I feel like this is a good time to say it's arithmetic, not arithmetic. That's different. Okay, so arithmetic. All right, write an explicit formula to represent the sequence. So here's your explicit formula. A sub n equals a sub 1 plus n minus 1 times d. So I know her first term is 100. And then she's adding $25 per day. Write a recursive model. All right, let's set it up. All right, so it's always two parts. Include your first term. First term is 100. If you want the next term, take the previous term and do what? Well, we were adding 25 each time. So plus 25. And there you go. All right, next question. Which of the following would represent the graph of the sequence 2n plus 1? Explain your choice. All right, well, if you want, you could even figure out a few terms of this, like a sub 1 would be 2 times 1, which is 2, plus 1, which is 3. A sub 2 would be 2 times 2, which is 4, plus 1, which is 5. And a sub 3 would be 2 times 3, which is 6, plus 1, which is 7. And that seems like a good amount if you even wanted to. You don't need to do that, but you might want to. So by looking at these choices, remember how we talked about by definition, a sequence starts with term 1. Now, I gotta be honest, that's like 99% of the time. Sometimes they'll specifically define a function to start at term 0. We'll cross that bridge when we get to it, but we'll say 99% of the time we're starting with term 1 because it feels weird to say the 0th term, the first term, right? So the first term is 3, right? We don't care about the 0th term right now. So I'm going to take out 1 as an option, and I'm going to take out 2. So right now we're between 3 and 4. They have the correct dots in there, but do we want to connect the dots? Is there such thing as a term 1.5? There is not. And that's why the correct choice is option 3. So our explanation really has to do with the domain of our sequences. So since the domain of sequences is the counting numbers, the dots shouldn't connect, and there's no 0th term. Okay, cool. Last two questions here. Oops. In an arithmetic sequence, the 4th term is 10, so a sub 4 represents the 4th term. The 7th term is 34. Write an explicit formula to represent the sequence. And remember, d is the slope, and that's going to help you figure out this problem. All right, so one thing you might want to do is just map this out. Okay, oops. What's the 4th term? All right, they gave you the 4th term is 10, and the 7th term is 34. Now, a real easy way to figure out your common difference is just by computing the slope. All right, so basically you have the coordinates 4, 10, and 7, 34. So what I can do is do 34 minus 10 over, now in the same order, 7 minus 4. That's 24 over 3, which is 8. Let's fill this in. Does this make sense? going forward by adding 8. This would be 18, 26, and then, 34. Now let's work backwards too. By subtracting 8 to go in the opposite direction, this would be 2, -6, and then -14. Now it is important to always work backwards to finding your first term because you're going to need that for your explicit function. A sub n equals a sub 1 plus n minus 1 times d. Alright, so remember you need the common difference, which we found was 8. And you're going to need the first term, which we just found was -14. So now we just substitute in what we need. And there you go. That's your explicit function, or explicit formula. All right, last question is an old regions question. So given f of 9 is -2, so that's the same thing as saying the ninth term is -2. They're just giving it in function notation. Which function can be used to generate the following sequence? All right, now first thing I'm noticing is that each time it looks like we're adding 0.75. Just by looking at the difference of those terms. So I'm figuring my common difference is 0.75. And my first term is -8. Okay, let's use my explicit formula here to help me out and substitute in what I know. I know the first term is -8, and I know the common difference is 0.75. So I'm just going to go ahead and substitute those in. I realize it says f of n. I'm just keeping it in terms of a sub n. Same idea. All right, so take a look at what we got so far. This one at B is looking really, oops, I substituted in the wrong thing. Hold on a second. This is 0.75. Okay, I was about to say this one at B looks really close because it has the right format, if you will, except for it's minus 0.75, as where for us we were going up by 0.75. So that's super close, but not quite it. So that one's actually out. It's super close, though. I don't see my option there. So what that tells me is this is probably in simplest form. So let's clean this up a little bit. I've got -8 plus 0.75n minus 0.75, right? By just distributing backwards here, that 0.75. Now from there, I'd almost rather not use green there. I'm noticing that I have a -8 and minus 0.75 that I should combine. So that's negative 8.75 plus 0.75n. Take a look at our options, and that looks like option C. Now, another thing we can do, and I mentioned this before, let's type that in our calculator and let's see if that actually makes sense. All right, so if I go to y equals, let's actually type in the one I chose, -8.75 plus 0.75x instead of n. All right, that looks good. Let's go to my table. So there's my first term at -8, and it looks like it keeps going up by 0.25 or 0.75, which is what we expected. And look at that. Your ninth term is -2. So you'll notice that I didn't end up even using this in the solution of my problem, but it was extra information that I could double check in my calculator if I wanted to. All right, and that concludes day 1 of arithmetic sequences. Tomorrow we'll move on to geometric. So remember, arithmetic means adding, tomorrow's geometric.